Hello everyone, we are still in the discrete mathematics and its applications, and we now discuss the solution to this exercise. Uh, so we want to find r to the power of n for n equals to 2, 3, 4, and so on, where r is given there. So let's start with r to the power of 1. This r itself, uh, is this relation. Now let's compute r to the power of 2, which is r to the power of 1. R composed with r to the power of 1. So what is this, right? So let's say you have a comma b to be a pair in R. Then you know that 2a is less than b, right? Now if b is such that b comma c is in R1, which is R, then you know that 2 times b is less than c. So from here you know that while a comma c is in R to the power of 2 if and only if uh, um, 2 times b and b itself is greater than uh, 2 times a, and you know that this is actually the same as uh, 2 times a plus 1 is less than or equal to b. So the smallest value b can get is 2a plus 1, because we have a and b natural numbers. And similarly here, the smallest value c can get is 2b plus 1. So therefore, uh, you know that a comma c is in r to the power of 2 if and only if 2b, if and only if you have a natural number b such that 2a is less than b, or 2a plus 1 is less than or equal to b, and 2b plus 1 is less than or equal to c. So that means um, 2 times 2a plus 1 plus 1 is less than or equal to c. So that is for a plus 3 less than or equal to c. Yeah. So that is the relation. So therefore you could write it here, a comma b, pairs of natural numbers, such that uh, for a plus 3 is less than or equal to c. Yeah. Or if you want, you could write it this way: set of pairs of natural numbers as for a plus 2 is less than c. Yeah. Now how about r to the power of 3? And this is r to the power of 2, circle r. So you start from before we continue with r to the power of 3, let's do some examples. So here, for example, if you know that for example 1 comma 3 is in r, and then you know that the smallest value such that 3 comma something is in r to the power of 1, then you must have actually that 3 comma 7 is here. So therefore from here you know that 1 comma 7 is in r to the power of 2. Note also that 1 comma 6 is not in r to the power of 2. Yeah. Why? Because smallest value from 1 you could go, smallest value you could go from 1 using r is 3. Now and then from there the smallest value from 3, the smallest value you could go using r to the power of 1 from 3 is 2 7. Yeah, so you cannot go to 6. So therefore 1 comma 6 is not in r to the power of 2. Yeah, so you know that that this is correct. Has to be, sorry, has to be B. Yeah, because this is the pair A comma B, right? Yeah. Now how about r to the power of 3? Well, we do the same thing here. Yeah, well, you multiply them using this equation. You multiply this by 2 and added 1. So therefore so 2 times 4a plus 3, let me just fix this first. Yeah, 2 times 4a plus 3, because 4a plus 3 is less than or equal to b, and then you take plus 1 less than or equal to b, because here, right, to like this, right? Yeah, or the same as a comma b and of 2. Let's say this is 8a plus 7 less than or equal to b, or say comma b. So number is set 8a plus 6 is less than. Now you could guess that actually r to the power of n is a set of, because you see the pattern there, right? If r to the power of 2, you have 4a plus 3 less than or equal to b, or 4a plus 2 less than b, right? Here this time you have, if you have r to the power of 3, you have 8a plus 7 less than or equal to b, or 8a plus 6 less than b. So therefore this could be seen that actually this is 2 to the power of n a plus 2 to the power of n minus 2 less than b. Yeah, so that's an expression that you could write for r to the power of n. Yeah, so that's the answer for this exercise. Now we let's stop here, and we will continue with the final slides on a result involving the composition of binary relation, powers of binary relation.